Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we go through collecting and estimating data. So obviously, before we understand what we mean by collecting and estimating data, we need to know what data actually is. So data, for our purposes, is just information. So we're collecting information usually from many people. So we might, collect data about people's eye colour, about their favourite sport, about the number of times per week they order takeaway, and so on. All of that is data. The information that we receive is data. And we're going to look at ways of collecting that data and estimating data when it's numerical. So, firstly, to the collecting part. Now, we need to make sure we know a couple of definitions. So, the first one we have to look at is population. So, when we talk about population in statistics, we mean everyone to whom a particular characteristic applies. And if we talk about a sample, you've probably come across sample before. You might have got a sample of chocolate where you don't get all of the chocolates, you just get a few types. So a sample is just a subset of the population. So it sometimes can be tricky to determine whether a group of people you have or a group of participants, whatever, is a population or a sample. It depends on the question you're trying to ask. So let's say I'm interested in learning about the most common eye colour or proportion of people that have a certain eye colour or whatever at Marist, okay? And let's say I'm just going to limit it to Marist, Canberra. So, if I want to know information about the eye colour of everyone at Marist, it might be tricky and time-consuming to ask every one of the 1,200 students. That takes quite a long time. So instead, what I might do, instead of asking everyone, I might ask only some students. So I might choose to just ask Year 8 students. If I ask just Year 8 students what their eye colour is, I find out data as to their eye colour, that might just give me an indication of the prevalence of eye colours for all students at Marist. So if I ask Year 8 students, there's about 200 Year 8 students, that'll obviously be much quicker than asking all 1,200 students. So in this case, all of the students at Marist from Year 7 to 12, they make up the population. The Year 8 students make up a sample in this case. So, everyone at Marist population, Year 8 students make up a sample, okay? So that is an example of where Year 8 students represent a sample, but what about when they're the whole population? Let's say, however, that I'm interested in collecting data on how people did in the Year 8 test. I want to find information about Year 8 test scores. So in this case, I obviously am interested in people who took the Year 8 test. But that is only Year 8 students. Only Year 8 students took the test. So when I'm interested in the Year 8 test scores, now Year 8 students are the whole population. They're not a sample because there's nobody else other than these Year 8 students who took the test. The Year 8 students are everyone to whom a characteristic applies. In this case, Year 8 students represent everyone who got a Year 8 test score because they took the test. So it can be tricky. Sometimes a certain group of people can be a population. Sometimes that same group of people is a sample. It depends on what you're trying to achieve with your data. So we need to look at how we can best sample. So please pause and copy this down if you need it. So as I said before, sometimes it would be very expensive and it would be tricky, time-consuming to ask everyone in a population. Imagine if you wanted to find information about, how often people exercise in Australia. I mean, you wouldn't want to ask all 25 million Australians. That'd just take too long. So that's why we have samples. Sometimes it's just not feasible to ask everyone in a population. Now, when we have a sample, what we want to do is we want to try as much as possible to have a random sample, and we want to do that to avoid bias. When we're picking a sample, the most important thing is we want it to be representative of the population. Okay, so if I wanted to find information as to how many hours per week people in Australia exercise, I don't want to ask a certain group of people that is going to skew my results. I wouldn't just go to a gym, for example, and ask everyone there how often they exercise, because they're not representative of the whole population. If I go to a gym, I'm asking people who I know already do at least a little bit of exercise, but I'm ignoring that there could be heaps and heaps of people out there who don't do exercise. So that's what we have to do when we're sampling. So if I want to know about how many hours per week people exercise in Australia, instead of going to a gym, instead of, say, going to a McDonald's or something like that, I would go somewhere else and I would make the sample random. So I might just stand, out on the streets in front of, say, a Woolworths or something like that, because that won't bias my results. Perhaps I'll send emails to, schools, workplaces, whatever. I want the people who participate in the study, I want the people who tell me how often they exercise, I want them to be random. I don't want to pick certain people, because that may give me results that don't indicate what the population is like. And that's precisely what a bias is. A bias is where you pick a sample that's more likely to yield a certain result. So another example I could give you, let's say I wanted to collect data as to the most popular sport here at Marist. Now, if I went to soccer training and I asked all the students there what is their favourite sport, I'm likely to encounter a bias. The students there are more likely to say soccer than someone who doesn't play soccer already. So if I went and I just asked everyone at soccer, what's your favourite sport? I might then get up at assembly and say, turns out soccer is the most important sport at Marist. Everyone would be like, well, hang on, Mr. Lark, what are you talking about? You only ask people at soccer training. If you asked different people, you would get a different result. So that's an example of bias. So if I want to know what the most popular sport at Marist is, I need to pick students randomly so that they are representative of the whole population. I'm not going to ask a certain group of people who I know already likes footy or already likes soccer. I want the people who give me the data to be completely random. All right, the last thing I want to go through today is estimating data. So let's say I did go ahead and I wanted to find data on everyone at Marist what their favourite sport is. So instead of going to soccer training or footy training, I just asked Year 8 students at Marist, because, I can be confident that they're going to be reasonably representative of all the students at Marist. There's no reason that I would expect a bias. I wouldn't expect Year 8 students to be more likely than anybody else at the school to like NRL or soccer or whatever. So let's say I asked the 200 Year 8 students their favourite sport, 90% said NRL. I can use that to estimate how many people at the whole college, how many people out of the whole population support a sport. So I know that 90 out of 200 people in Year 8 said NRL was their favourite sport. So I can write this as a proportion or a fraction. So 9 out of every 20 people in Year 8 said NRL was their favourite sport. So because I believe that my sample is reasonably representative of the whole population, in this case, Marist students, the whole population, because I'm interested in the favourite sport of students at Marist, because of that, I can estimate that if 9 out of every 20 students in Year 8 said NRL was their favourite sport, then 9 out of 20 people, out of all the people at Marist, would say that NRL is their favourite sport. So I am going to estimate that 9/20ths of all of the 1,200 students would say that NRL is their favourite sport. Now remember, of means times, so 9 over 20 times 1,200. Remember, you just times these two numbers together and then divide by 20. And you can use your calculator for this. You should get the answer 540. So from my sample, 9/20ths of Year 8 students said NRL was their favourite sport. So I am estimating that if I asked every single person at Marist, all of the 1,200 students, what is their favourite sport, that 540 would say NRL. Easy as that. Thank you for tuning in. This has been the luckiest maths teacher in the world. Have a great day.